You're here because you want to get a real handle on how artificial intelligence is shaking things up in healthcare, and you want to do it efficiently. We've sifted through the core information to bring you the insights that truly matter.
Exactly. We've looked at some, really well-structured material that lays out the groundwork of AI in healthcare. Makes it pretty easy to grasp, actually, no matter where you're starting. This is about getting you up to speed on what's critical.
Absolutely. Our sources cover quite a range, from the fundamental building blocks of AI
Yeah.
all the way to how it's being applied, in practice. Our aim is to distill it all down, highlight the key takeaways, and connect these, complex ideas to real-world healthcare scenarios. Okay, let's dive in, shall we?
Let's start by maybe just establishing a clear understanding of AI itself. It's a term that gets thrown around a lot, right?
Yeah.
So it's important to break down its different facets. Our source material uses a helpful analogy here, nested circles.
Right, the AI hierarchy. Picture it like this. The largest circle represents artificial intelligence, or AI. This is the big picture, the whole field of creating computer systems that can do tasks that normally need human intelligence, like learning and problem solving. In healthcare, maybe analyzing tons of medical data or helping with diagnoses.
Precisely. Now, inside that big AI circle, there's a smaller one, machine learning, or ML. This is a specific way to achieve AI where computers learn from data to get better at a task without being explicitly programmed for every single step.
So instead of feeding it rigid instructions, you give it data, and it figures out the patterns itself. Like our source mentions ML predicting disease risks from patient data. The more data it sees, the better it gets.
Exactly right. And then right at the core, the smallest circle, that's deep learning.
Deep learning sounds like the really advanced stuff.
It is. It's a more specialized type of machine learning using these multi-layered artificial neural networks. You can sort of think of them as being inspired by how the human brain is structured. This layered setup makes deep learning really good at finding very subtle, complex patterns in unstructured data, things like medical images or even picking up nuances in doctor's notes.
Okay, so if I'm tracking this, AI is the big umbrella concept, making machines smart. Machine learning is a method within AI learning from data, and deep learning is like a subset of ML, really good at complex pattern stuff, especially with things like images. Is that about right?
That's a perfect summary. And our source material gives a really insightful comparison of these three approaches. It looks at, how they're programmed, how much human input they need, the data requirements, and importantly, how easy it is to figure out why they made a decision.
Let's dig into that comparison.
Yeah.
It mentions traditional AI is very rule-based, so humans have to explicitly program all the rules it follows.
That's right. It needs extensive rule design from us. Machine learning, on the other hand, is data-driven. The algorithms learn directly from whatever data you give them. And deep learning kind of takes that a step further, aiming for self-learning right from the raw data, with less need for something called feature engineering.
Feature engineering, what's that exactly?
That's basically the process where humans manually select and transform the raw data into features characteristics that the ML model can learn from effectively. Deep learning often tries to automate a lot of that. And yeah, you're right about the data needs. Traditional AI might need moderate amounts, ML needs substantial amounts, and deep learning, well, it often requires truly massive data sets because of its complexity.
And what about understanding why an AI decision was made? The comparison talks about interpretability.
Exactly. Traditional rule-based AI is usually highly interpretable because, well, humans wrote the rules, you can trace the logic. Machine learning can sometimes be more of a black box. You see the input, you see the output, but the internal reasoning isn't always crystal clear. And deep learning, with those complex neural networks, typically has low interpretability.
Interesting. So the more powerful and complex the AI, potentially the harder it is to peek inside and see how it works.
Yeah.
But I guess that complexity lets it tackle tougher problems. The source suggests traditional AI for simple tasks, ML for moderately complex ones, and deep learning for the really complex, unstructured stuff.
Spot on. Now let's make this more concrete. Let's look at some specific healthcare examples from our sources.
Yes, let's see it in action. The first one is AI in diagnosis. It mentions MIT researchers developing systems that can process patient data way beyond what a human could handle alone. What kind of impact are we talking about there?
Well, imagine a system analyzing not just a few data points, but thousands, lab results, history, genetics, maybe spotting patterns a doctor, under time pressure with tons of info might miss. Could mean earlier, more accurate diagnoses.
Okay, next up, ML in predictive analytics. The source explains ML models predicting risks like sepsis or hospital readmissions. How does that work practically?
Think of it like this. You train an ML model on historical data from lots of patients who, say, developed sepsis. It learns to spot common factors, patterns in their data that showed up before they got sick. Then, with a new patient showing similar patterns, it flags them as higher risk. This lets doctors intervene before things get critical.
Wow, yeah, that could be huge for prevention. And finally, deep learning in medical imaging. The source says deep neural networks analyze X-rays, retinal scans, detecting tumors or early diabetic retinopathy signs, sometimes as accurately as human experts. That's pretty amazing.
It really is. These deep learning models get trained on enormous sets of medical images, learning to recognize those super subtle visual cues that signal disease. Like with diabetic retinopathy, the early signs can be faint, but a well-trained model can often pick them up, sometimes even before a specialist might.
Okay, so we've gone from the big idea of AI down through ML and the power of deep learning and seen real examples in diagnosis, prediction, and imaging.